Welcome to MyProjectBazaar.com. Now we are going to discuss about our project Nonlinear Dimensionality Reduction and Gaussian process based classification method for smoke detection. Let's see the abstract of our project. The smoke provides the important clues for early detection of fire. The traditional fire detector, such as ionized sensors, requires to be installed closely to fire or smoke. In addition to this, unlike the objects such as the face or man-made buildings, the variation of smoke, shape, color, density, and textures are largely different from each other. So it is very difficult to extract the robust features from images to represent the smoke. In order to make the detection process easier, the smoke image features are extracted using the local binary pattern method. And the local binary pattern encodes the difference between local regions and describes the texture information as well. The local binary pattern features have been widely used in face recognition, texture classifications, and smoke detection because of its discriminative capability, computational efficiency, and low illumination sensitivity. And the extracted features are trained for the dataset images. After the extraction, the features are mapped by using the kernel principal component analysis, and PCA is defined as the orthogonal linear transformation, which is often used to transform the data into a new subspace. And then the Gaussian process regression algorithm is used for the classification process. The Gaussian process regression algorithm, which predict the labels of the input image. After that, the classification, the performance of the proposed system is evaluated by using the precision, recall, accuracy, sensitivity, specificity values. The performance values which shows that the proposed system which performs and produces better results than the existing systems. Now we are going to see the flow diagram of our project. That's the first the input image is acquired. So the input image acquisitions, the images are taken from the datasets, and the dataset images which consist of the smoke and non-smoke images. So we are going to classify the smoke and non-smoke images. After that, the pre-processing stage. In that stage, we are going to pre-process the image by doing the operations of the image resize and the gray conversion. In that image resize, we are going to convert the image into 256 cross 256 sized images. So making that all the images equal in the datasets, which makes the process easier. And after that, the RGB to gray conversion. The original image, which consists of the three channels, red, green, and blue channels, and three channels, which the three channel combined image is called as a RGB image, and we are going to convert the RGB image into two channel image, that is a gray image, which is a black and white. So here we are converting the original RGB image into the gray image. After that pre-processing, we are going to extract the features by using the local binary pattern features. In that, the local binary pattern features, which encodes the local texture informations which you can use for the task such as the classification, detection, and recognition. Here we are going to classify the function partition the input image into non-overlapping cells to collect the information over larger regions and select the larger cell sizes. However, when you increase the cell size, you will lose the local details. So here we are using the local binary pattern features to extract the image features. After that, the feature mapping. The feature mapping is nothing but the dimensionality reduction. So for the better process, we are going to reduce the dimensionality of the extracting features. Here we are using the kernel principal component analysis, which is nothing but the extensions of the principal component analysis process. The kernel principal component analysis is a dimensional reduction process. The advantages of dimensionality reduction, such as it reduces the time and storage space required. The removal of multicollinearity improves the performance of the machine learning model. And the principal component analysis can be employed in a non-linear way by means of the kernel trick. After that, the classification. The classification is done by using the Gaussian process regression methods. So we apply a Gaussian process regression to model the classification. as a Gaussian process by imposing the Gaussian priors on both data and hyperparameters. The GPR is just based on a non-parametric Bayesian methodology which models the classification as a Gaussian process. The smoothness is achieved by imposing the Gaussian priors over both data and the hyperparameters. By using this GPR method, we are going to classify the input image as whether the smoke image or the non-smoke image. After that classification, the performance evaluation of the system is analyzed by the parameters such as accuracy, precision, recall, sensitivity and specificity values. Let's we see the running procedure of our project. If you want to run this project, just right click on the main guide.ym file and select the run button, and a guide will open. And if you want to select the input image, just click on the input image button, and a dialog box will open which asks for the dataset image, and select any one of the image, the dataset which consists of both the non-smoke image and smoke image. So I just select one image, and the original input image is appeared on the screen, and we go for the pre-processing. In that image resize, select the image resize means the image is resized into 256 cross 256 size pixels. After that, the gray conversion. In the gray conversion, the original image is transformed into the grayscale image. After that, we are going to feature extraction. If we select the feature extraction button, it will extract the feature values, which shows that the image feature values. And feature mapping. Select the feature mapping button means the optimized features are shown, and the classification. That classification which gives the results whether the image is affected by smoke or non-smoke image, which is a non-smoke image, so non-smoke images appeared, and the performance evaluation in that which shows the performance of the systems, and the graph will shows the performance of the systems. And that's it. Thank you. Thanks for listening.